In Lesson 14, Precalculus, we continue graphing rational functions. Now we're going to look at the graphs of some functions where the graphs do not have vertical asymptotes. This is section 3.3 in the college algebra textbook. Let's look at f of x equals x squared minus 9 over x squared plus 4. The domain of this function, well, looking at the denominator here, there is no value of x, no real value of x, that is going to give me a 0 in the denominator. So I can say the domain is all real numbers here. For the holes in the graph, if I factor my function into x minus 3 times x plus 3 over x squared plus 4, I can see there are no common factors between the numerator and denominator, so there will not be any holes here. Then, how about x-intercepts? Well, again, let's look at f of x in its factored form, x minus 3 times x plus 3 over x squared plus 4. And the x-intercepts occur when f of x is set equal to 0, which would be when x minus 3 or x plus 3 is equal to 0. X-intercepts then will occur when x is equal to 3 or x is equal to negative 3 at the points on the graph 3, 0 and negative 3, 0. Okay, two x-intercepts. For y-intercepts, I set x equal to 0. I will have y equals 0 squared minus 9 over 0 squared plus 4. Simplifying to negative 9/4, we have one y-intercept at the point 0, negative 9/4. Now, vertical asymptotes. Notice that there are no linear factors in the denominator here. There will not be any vertical asymptotes, so we can say none here. Horizontal asymptote, we would look at the degree of the numerator and the degree of the denominator. Since they're the same here, we take the leading coefficient of the numerator over the leading coefficient of the denominator to give us a horizontal asymptote, y equals 1. And moving on to graphing, putting down all the information we have so far, let's plot this information on a graph. We have x-intercepts at negative 3, 0 and at 3, 0. We have a y-intercept at 0, negative 9/4, no vertical asymptotes, and we have a horizontal asymptote, y equals 1. Okay, from here, let's see what we need to do to graph this function. Well, the only place that my graph will cross from above to below the x-axis would be at either vertical asymptotes or x-intercepts. Since there are no vertical asymptotes here, I'm going to pay some attention to the x-intercepts. Between those two x-intercepts at negative 3, 0 and 3, 0, I can see that I have the y-intercept below the x-axis, and what that tells me is that the graph will not be above the x-axis at all between negative 3 and 3, and so I'm going to go ahead and sketch that part of the graph between x equals negative 3 and x equals 3 below the x-axis, passing through that y-intercept. And then what's happening to the left of x equals negative 3? Well, if we look at negative 3, 0, the negative 3 here came from the factor of x plus 3 in the numerator, which is raised to a power of 1. Thus, the graph is going to cross the x-axis at negative 3, 0. At 3, 0, the 3 came from the factor in the numerator of x minus 3, raised to an odd power of 1. And so we can see that the graph again will cross the x-axis at x equals 3. And both going to the left and going to the right, you can see that we're approaching the horizontal asymptote. So here we have the graph of a rational function that does not have any vertical asymptotes. Try on your own number 2. Find domain, holes, intercepts, and asymptotes, and then graph the rational function r of x equals 2x over x squared plus 1.